Alright, this video is going to cover multiplying decimals with estimation to check to make sure that our answer is close. Estimation is always incredibly helpful because it'll help you determine if you made a larger mistake within your multiplication. So that's what we would always want to start with. When we're multiplying, the decimal, again, is always an important piece. So you always want to double check that your decimal is in the correct place. Let's go through the first example, starting with our estimate. 3 and 27/100 is about 3. If we were to round it to the nice whole number, it'd be 3, because 2 isn't enough to round it up. Multiplied by 5 gives us about 15, so we know that our answer should be somewhere close to 15. When we set up the multiplication problem, we'll put this first digit on top. It's also helpful because it has more digits in it. 3 and 27/100. When we're working with multiplication, that is the time that we don't need to line up the decimal point. So 5 can go directly underneath with our multiplication. And then we're going to multiply the 5 to every single digit in our problem, just as if there weren't a decimal there to begin with. 5 times 7 gives us 35. We carry the 3, still saying 35. 5 times 2 gives us 10, plus 3 more is 13. Carry the 1, it still says 13. 5 times 3 is 15, plus 1 more is 16. This time, that 1's going to go straight down because there isn't a digit to the left to carry it to. So at this point, it looks like we've got 1,635, but that wouldn't make sense because our estimate was about 15. So we can use our estimate to determine where our decimal is going to be. If we wanted it close to 15, it would have to be here, because 16 is close to 15. The other way to check is to count how many digits were to the right or after our decimal and each of our factors. The numbers we're multiplying together are what we call factors. So in this case, we have 1, 2 digits to the right in their first factor, and 0 digits in the second one. Meaning, in our answer, there needs to be 2 digits to the right of our decimal. 1, 2. Making our final answer 16 and 35/100. Let's try the next one. We see that we have 5/100 multiplied by 43. 5/100, that's super small. A couple different ways that we could estimate. This is about 0 times 43, which gives us 0, meaning it's going to be a small value or a 1-digit number. Or, if we round it to the 10th place, that would make it 1/10 times 43. If we're multiplying by 1/10, rather than multiplying, we're going to divide and move it one place over. So it may be close to 4 3/10. 1/10 over. So we know it's going to be somewhere in between these two. Now, again, listed first, we'll put it on top. 5/100 multiplied by 43. With multiplication, we don't need to line up the decimal, and we'll multiply both numbers out. 3 times 5, starting with the 3. 3 times 5 is 15. Carry the 1. Notice organization is incredibly important. 3 times 0 is 0, plus 1 is 1. And we've multiplied the 3 to all of our digits in our first factor. So we're finished with the 3, and we're finished with that 1. So I like to cross a line through it so I know that I don't use it again. This 4 is in the tens place, not in the ones place. So we have to hold 0 to show that it's not just 4 being multiplied, it's 40 being multiplied. So we do that by putting a 0 down here. We have to hold that place value. So now it's 4 times 5, which is 20. 0 down here. The 2 goes up, so it's still 20. And then 4 times 0 is 0, plus 2 more is 2. And then we've multiplied the 4 to all of our digits. So now we can add them all up. 5, 1, and 2. In our problem, there are 2 digits in the first one, 0 digits in the second one, so that means in our answer we need 2 digits. We add them all up to the right of our decimal, so that would be 1, 2. So our answer is 2 and 15/100ths. That is somewhere between the 0 and 4 3/10. So we know that our answer is close. Another one. You'll notice that as we go through, we're adding more digits to the problem, and that's okay. This first one, if we estimate, that's about 1 multiplied by about 6. So our answer should be close to 6. If we put the first one on top, 1 and 12/100ths multiplied by 6 and 1/10. We multiply the 1 out first. 1 times 2 is 2. 1 times 1 is 1. 1 times this second one is also 1. Multiplying by 1, so it stayed the same. So we're finished with the 1. Now when we're multiplying the 6 out, we have to hold the place value of the 1. So we put a 0. This is super important. Now we multiply the 6. 6 times 2 is 12. Carry the 1, so it still says 12. 6 times 1 is 6, plus 1 more is 7. And then 6 times 1 is 6 again. Then when we add them together, we get 2, 3, 8, and 6. Now we have to determine where the decimal will go. Our estimate was 6. That's a single digit. So that would make sense for our decimal to go in between the 6 and the 8. So let's double check. We have 2 digits to the right of our decimal. And then we have 1 more digit to the right of our decimal. So in all, we need 3 digits to the right of our decimal. 1, 2, 3. So 6 and 832 thousandths would be our answer. For this problem, if we have the 51/100ths, that's about 5/10, about half, multiplied by 76/100ths is about 1, so half of 1 is about half. Or if we said that 51/100ths to the nearest whole number, it'd be 1 times 1, which is 1. So it's somewhere in between here, somewhere in between. We put the 51/100ths on top, multiplied by the 76/100ths. You'll notice that I didn't put the zeros there because we're not adding any additional value, and that's okay. You could put them there. And then when we multiply them out, 6 times 1 is 6. 6 times 5 is 30. And we've multiplied the 6. So we're done with the 6. Now we have to hold that place value by drawing a 0. And then multiply out the 7. 7 times 1 is 7. 7 times 5 is 35. There's no more place to put the 3 to carry it, so it goes straight down. We'll add them together. And then determine where the decimal would go. Again, it should be somewhere between 5/10 and 1, or somewhere near there, so we'll want to double check by counting our digits to the right of the decimal. Here we have 2 digits to the right. Here we have 2 again. So in all, we need 4 digits to the right of our decimal. 1, 2, 3, 4, so our decimal must go here for our final answer. We'll do just one more. Let's go with this one. 9 and 3/10 is about 9. Multiplied 706 thousandths is about 1 if we rounded to the nearest whole number. So our answer should be near 9. I like to put the number with the most digits on top. So we're going to actually put 0 and 706 thousandths on top, multiplied by 9 and 3/10. You'll notice the first factor has 3 digits to the right of the decimal. The second factor has 1 digit to the right of our decimal, so we know that in all, we'll have to have 4 digits to the right of our decimal. So let's multiply it out. 3 times 6 is 18, carry the 1. 3 times 0 is 0, plus 1 is 1. Notice I'm putting that directly underneath. 3 times 7 is 21, so the 1 goes here, 2 is carried. It still says 21. And then 3 times 0 is 0, plus 2 is 2. Okay, so we've taken care of the 2, the 1, and the 3, but now we have to hold the place value. So we'll add a 0, and then multiply out the 9. 9 times 6 is 54, so the 4 goes here, the 5 is carried up. We cross out that 1 to make sure that we're not getting confused. 9 times 0 is 0, plus 5 is still 5. 9 times 7 is 63, the 3 goes down, the 6 goes up, so it still says 63, top down. 9 times 0 is 0, plus 6 is 6. So we've multiplied both of our digits out. So now we can add them all together, giving us 8, 5, 6, 5, 6. And now we have to determine place value. With our decimal, we know it should be about 6. We need 4 digits. We determined to the right of the decimal, so that's 1, 2, 3, 4. Meaning our final answer is going to look like this. So when we're working with decimals, an estimate is super helpful to check to make sure that our answers are close. It's not going to be exact, but it should be close, especially with place value and where a decimal is located. We count the number of decimals in the factor, a factor being the numbers we multiply together to get our final answer.